Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic center of gravity of solid bodies. Let's go to the numerical. A body consists of a right circular solid cone of height 40 mm and radius 30 mm placed on a solid hemisphere of radius 30 mm of the same material. Find the position of center of the body. So this is the given diagram. Here you can see a right circular solid cone that is placed over a hemisphere. If you have a sphere, then a cut, that means 90-degree cut at the middle plane, then you will get the hemisphere, okay, with the volume of the sphere. Okay, so here this is the joining base for the two solid segments. One is right circular solid cone, another one is the hemisphere. So for our convenient, I am going to split this into two segments. One is hemisphere, another one is the circular cone, right circular solid cone. And then here, this is symmetry about its vertical axis. So here it is not needed to calculate the value of x bar, because here this will be the bottommost line. Okay, that means this edge D of the hemisphere, that is the bottommost point or bottommost line, that will act a reference for the y bar calculation. And this edge A that you can take, that is the leftmost line or the point. Okay, so here you can see this is the leftmost line, and that will act the reference for the x bar calculation. Okay, this will act a reference axis for x bar calculation. The bottommost line or the point or the bottommost line passes through the bottommost point. The reference axis for y bar calculation. Here you can see, since it is symmetry about the vertical axis, the center of gravity of the body lies on anywhere on the vertical axis. So the distance of center of gravity from the reference axis for x bar, the leftmost line, to the CG of the entire body, that will be same and equal to the radius 30 mm. So here it is not needed to calculate the value of x bar, because from the diagram itself we can see x bar equal to the radius, this one. If we had taken the center, this one is O, AO, 30 mm radius, that is x bar. So separately we don't want to calculate x bar. Only the thing is we have to calculate the value of y bar. Here, as I mentioned earlier, I'm going to separate this into two segments. First one, hemisphere. Second one, the right circular cone. So, and these two considered segments are volumes. Okay, so V1 Y1 plus V2 Y2 divided by V1 plus V2. Okay, and then here schematically you can see this is the hemisphere. Okay, that means a 90-degree cut on its mid axis. Okay, this is the hemisphere. Over the hemisphere, there is a right circular cone is there. That means you can say like this. This will be the cone placed over the hemisphere. And this is the common face or the joining base. Okay. And this will be the vertical axis, like that we can consider, passes through the center. So the radius of the hemisphere, this distance. Okay. That will be the radius of the hemisphere and also the radius of the base circle of the right circular cone. Okay. This diagram only given schematically here. So first thing, and then guys, here the volume of the hemisphere, and then the distance of center of gravity of the hemisphere from the base or this edge, point D, that formulas and all we discussed in a separate video, an overview of center of gravity. That video link is attached with the description box of this video. Same, this concept for right circular cone, what will be the center of gravity, everything we explained, I explained there in that video. An overview of center of gravity, that video link is attached with this video in the description box. Same way, this formula, the derivation of the formula y bar, x bar, or even z bar values in terms of areas, in terms of volume from mass or weight, that is center of gravity by moment method. That is a separate video. That video link also attached with the description box of this video. Okay. So for a better understanding, you just to see the two videos, center of gravity by moment method, center of gravity, and overview of center of gravity. Both the video links are attached in the description box of the video, of this video. So go to the description box of this video, watch the two reference video for better understanding of this numerical. So I just start with the first segment, that is hemisphere. Okay. Here you can see the hemisphere, that is the segment 1. Here we need V1 and also Y1. The formula V1, that equal to, we know the volume of the sphere 4 by 3 by r cube, it is half of that. So it will be 2 by 3 pi r cube. Okay. So here you can see the radius r, that is given 30 mm. So this equal to 2 pi 3 multiplied with pi multiplied with r equal to 30 power 3. Then by simplification, we will get the value of V1, that is 18,000 pi. In terms of pi, here I substituted. You can put the value pi 3.14 or 22 by 7, and further simplification also you can do, because here also pi, here also pi, here also pi, here also pi, that we can take commonly in the numerator and denominator, then we can eliminate. Okay, that's why I just keep the value of volume in terms of pi. Okay, so this is 18,000 pi in terms of mm cube. Then Y1, the hemisphere, the formula, just to refer the video, an overview of center of gravity, which is given in the description box. So here, from the base to the CG1, the CG1 that will lies on this vertical axis, for an example, if it is here, CG1, from this base or the point O, that will be 3r by 8 the distance, or from the point D, that will be 5r by 8. That distance is 5r by 8. Okay. So the Y1, and then here you can see this D, that lies on the reference axis for Y bar calculation. So Y1, that is 5r by 8. Okay. So 5 multiplied with the radius of the hemisphere 30 divided by 8. By simplifying, we will get y1 equal 18.75 mm. Okay, that is y1. Now, we have to do the same thing for the second segment, that is right circular solid cone. Okay, segment 2. Same way, V2 we have to calculate. The V2 for the right circular solid cone, that is 1 by 3 pi r square h. Radius is 30 mm, h height is 40 mm. Substitute the values. 1 by 3 multiplied with the pi, radius 30. So 30 square multiplied with the height 40 mm. Then by simplifying, here also you can take in terms of 5. So V2, that we will get 12,000 pi in terms of mm cube. Okay. Then Y2. Here, this is right circular solid cone. From the base, the CG2, center of gravity of the right circular cone, that will be at a distance from the base, that is h by 4, 1 by 4th h. From the point C, that will be 3 by 4th h. From the base point O, that will be 1 by 4th h. These things and all we elaborately discussed on the video and overview of center of gravity. That video link is given in the description box. For reference, you can see that video also. And then, so Y2. Here, guys, from this point O, that is h by 4, CG2. But we need the distance from the reference axis y bar. That means from here. That means we need this total distance. Okay, that is Y2. So from this distance, OD, we know that that is also radius. The radius plus this distance, h by 4. Okay, so that will be radius of the hemisphere or right circular cone, whatever, plus h by 4. From here to here, that is radius. Here to here, radius plus h by 4, that is Y2. The distance of center of gravity of the right circular cone, CG2, from reference axis for y bar calculation. So here the radius, that is 30 mm plus h 40 mm divided by 2. Okay. So we will get the Y2 that equal to, okay, 40 divided by 4. That means we will get 10. So we will get 40 mm. Okay, that is Y2 equal to 40 mm. Then substitute all the values in the y bar formula. V1, Y1, V2, Y2, everything we have to substitute in the formula. So V1, that is 18,000 pi multiplied with Y1, that is 18.75, plus V2, we got the value 12,000 pi mm cube, 12,000 pi multiplied with Y2, that is 40. The whole divided by V1, that is 18,000 pi, then plus V2, that is 12,000 pi. You can take commonly the value of pi in the numerator and denominator. That means we can write this as pi. Here also pi, here also pi. Take that pi commonly. The remaining value, 18,000 multiplied with 18.75 plus 12,000 multiplied with 40. Okay, for that I had taken the pi commonly. Then this one, 18,000 plus 12,000 pi, we will get actually 30,000, whatever. That equal to 30,000 pi. So here you can see this pi and pi will cancel each other. Then we got the value of y bar that equal to 27.3 mm. Okay, 27.3 mm. So here you can see this is the value of y bar. The distance of center of gravity of the entire body from the reference axis or for y bar calculation. That means here you can see this will be at a distance. That means, this is the reference axis for y bar. It is at 27.3. From here to here, it is 30. So it will be less than that. That means the CG of that entire section will be here. This is at a distance from here. That is 27.3 mm. Okay, from the reference axis for y bar calculation, which is given at the, that means bottommost line, or the line passes through the bottommost point. Okay, I hope you all understand this video. Don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver, for more videos as we discussed here. Okay. Thank you guys. Thanks for watching.